All right, we'll go ahead and get started. We have just about everybody. All right, let me share. Sorry, I have to rearrange everything here. All righty. Okay, let's see. We were on slide 12. Oops. Okay, so we had been talking about latitude, and I was about to give you a little bit on the Earth's revolution around the sun and its tilt and some lines of latitude, and I'll tell you why in a minute. But basically, when the sun strikes the Earth, it will strike it at different angles depending on the season you're in. Okay, and that's because several billion years ago, the Earth was struck by a large object. They suspect it was a large asteroid, and it was such an impact that it actually knocked the Earth off of its upright axis. So the Earth is actually tilted by 23.5 degrees. And they think that this is actually when the moon formed too. It knocked a big chunk off of the Earth and formed its moon. So during the year, as the Earth orbits around the sun, you'll see changes in the Earth's angle relative to the surface of the Earth. And that's why we get seasons. And we're going to talk about some of the other prominent lines of latitude that have special names and why they're prominent. Okay, so just hang tight and you can watch this video. Actually, I have to stop share for a second because I don't think I shared my sound. That should really be a default that it shares the sound. Okay, here we go.
You know that Earth orbits the sun, right? And that it takes a full year for our planet to complete its orbit? Earth also rotates like a slightly tilted spinning top. Earth remains tilted in the same direction all year round as we orbit the sun. But that means the sun's light shines differently on Earth at different times of the year. Let's look at Earth when it's winter in the northern hemisphere. Observe how the North Pole tips away from the sun. This means that sunlight strikes the northern hemisphere at a shallow angle for a short period of time. This is why winter weather is generally cool, with short days and long nights. As Earth orbits the sun, we move towards spring in the northern hemisphere. Now Earth is tilted neither toward nor away from the sun, as day and night are about equal in length. As we make our way to the summer months, notice that Earth is still tilted in the same direction, only now on the other side of our orbit. The North Pole is tipping toward the sun. Sunlight strikes the northern hemisphere more directly, and the sun stays in the sky for a longer time. Compared to winter, summer days are warmer, and the sun stays in the sky much longer. Notice, too, that while it's summer in the northern hemisphere, it's winter in the southern hemisphere. Because of Earth's tilt, the seasons are reversed. We observed how Earth's tilt creates the different seasons throughout the year. How does this affect life? Plant life and other photosynthesizers, we call them primary producers, depend on sunlight. they respond to the changes in the seasons. Earth-orbiting satellites measure the amount of carbon dioxide absorbed by these primary producers. Bright regions on this map show where they devour the most carbon dioxide, turning light from the sun into oxygen and natural sugars. In spring, when sunshine strikes the cold waters of the North Pacific, productivity skyrockets. Phytoplankton and other microscopic photosynthesizers form the base of the ocean food web, and all ocean life responds to changes in the seasons. On land, forests grow green during the spring, brightening the continents. During winter, continents in this view turn dark from a lack of photosynthesis.
Okay, so I like that video particularly because it adds in that extra piece at the end showing how the Earth's tilt really affects the productivity of organisms, especially in the ocean. Okay, so I mentioned that there were some key, yes, Owen.
Ellie Ferraro's Zoom is not working, that's why she's not here.
Who's?
Ellie Ferraro.
Okay, thank you. Okay, so let's talk about some of those key lines of latitude, and I'll list them again for you on another page. But during what we call the winter solstice in the Northern Hemisphere, that is December 21st, which many of you may know is considered the start of winter. That is going to be the shortest day of the year in this area. And at this time of year, the sun's rays will directly strike at the degree latitude of 23.5 degrees south. Okay, so at 23.5 degrees south, we consider that a major line of latitude, and we call it the Tropic of Capricorn. Okay, because that is their longest day of the year. Below that, at 66.5 degrees south, is the Antarctic Circle. And the reason they consider this line significant is because below that line, in the Southern Hemisphere, at that time of year, there's 24 hours of sunlight. Okay, so 24 hours of sunlight, what do you think happens up here above the Arctic? Catherine?
There's 0 hours of sunlight.
Right, we have 24 hours of darkness. So in the winter above this line, which is called the Arctic Circle at 66.5 degrees north, there will be no sunlight during the northern winter. One more line then that you need to know is during the summer in the Northern Hemisphere, which starts June 21st and happens to be the longest time of year for us, at 23.5 degrees north, which is where the sun is most directly striking the longest, that is called the Tropic of Cancer. Okay, so the 23.5 north and south are the two tropic lines. The upper one is Cancer, the lower one is Capricorn. I remember those, the order, because Cancer comes before Capricorn in the alphabet, so I know that one is above Capricorn on the globe. And then, of course, south of the Antarctic Circle, the sun would never rise, and north of the Arctic Circle, it would be 24 hours of daylight. This is just a general summary showing the way the Earth would look as it goes orbits around the sun. And then here's a list of those lines, just in case you didn't get those written. So you are responsible for knowing these 5 latitude lines by name. So I'll give you a second to make sure you have those written down. Okay, and you can always go back to the slide presentation and fill those in later as well. Okay, so If sailors wanted to, because the sun's angle changes by season and strikes certain latitudes best during certain seasons, they could technically, while out at sea, correct for the time of year, figure out approximately which latitude they were on, and use that to help navigate. However, that's pretty unreasonable. A lot of calculations would have to be done in order to get a fairly accurate location. So there's actually an even easier way for sailors, at least of the old times, to determine their latitude. And it was based on using the angle to the North Star, which is called Polaris. Let me just show you on this slide where the North Star is located. Now, the North Star can only be seen in the Northern Hemisphere. So there is no equivalent in the Southern Hemisphere. There's no Southern Star. So this only worked for sailors sailing in the Northern Oceans. Many of you probably know how to find the Big Dipper in the sky because it's a pretty bright constellation. But the Big Dipper basically has a handle and then a scoop. The two end stars on the Big Dipper are called the pointer stars, and that is because they point toward Polaris. So as if you were like dumping it out and it would pour into Polaris there. Polaris is the brightest star in the sky. However, you can't just look at the star or the sky and look for the brightest object and say it's Polaris, because there are also planets that can be seen with the naked eye, and those are actually brighter than Polaris. So to correctly identify Polaris, you need to find your Big Dipper and then follow the pointer stars. So how was Polaris useful to the sailors? Well, the interesting thing about Polaris is directly over top of the Earth's axis. So it is directly over top of the North Pole. And when the Earth goes through a 24-hour rotation, Polaris never changes location in the sky. Okay, every other star looks as though it is moving when in fact it's the Earth that's rotating. But here's a time-elapsed exposure. Polaris is located right here, and over a 24-hour period, it will appear that the stars are circling that point. So this is a fixed location that the sailors could use to measure angle off of to figure their latitude. Because remember, latitude is an angle measurement. Now, you're not going to have to calculate a latitude, all right? So I'm just going to show you some of the tools that the sailors did use to measure angles by using the North Star. The first one was called a cross staff, and it basically looked like a cross, and the sailor would hold it up to their eye, and the bottom of this T they would hold even with the horizon, or what would have been like the horizon, and then they would eyeball it so that the top of this, they would be able to see Polaris right at its tip. And then they learned how, trust me, I don't know the details, but they were able to somehow calculate the angle based on the length of the staff and the length of this piece in order to figure out that particular angle. And then that would give them their latitude. Here's just a diagram kind of showing those angles, but again, it's pretty complicated. It's actually this angle right here, so you won't need to know how to do that. Couple other tools they used. One was called an astrolabe. It's basically like a glorified protractor, and there was a little lever that they would move such that it would then line up with the North Star, and then they could measure the angle that way. That certainly sounds easier to me. And then this device here was called a sextant. You probably have heard of those because many ships will still carry them in the event that their navigation equipment goes down and they need to determine location in an emergency. So because sailors early on were able to figure out latitude, which was one of it was basically the lateral movement in the ocean. They were limited to moving in a left to right direction because longitude was a much harder challenge to figure out. And we'll talk in our next lesson about why longitude was so much more difficult. So essentially, in order to travel places, they could figure out their latitude and they would just sail in a straight line. So they would leave and they would sail across the same latitude to make sure they were going in a straight line. And then when they hit land, they would just turn and go south for a little while or north for a little while. And then they'd find a new latitude and they'd sail across. And they called this sailing in square waves. And this was one method that a lot of land mapping occurred by, because they were basically trying to map the coastlines, and they figured as long as they kept bumping into coastlines, then they could plot them on a map. Okay, so that is the end of lesson 1. So on the agenda, the only thing you need to do now is, if you didn't finish taking your detailed notes on pages 2 to 9, we have now covered all of that material, so you can go back and fill that in. The next lesson that will start is on pages 10 through 29, so that's a much longer section. Yes, Kelly?
So what time period was that when they like figured out how to do that?
The latitude or the longitude?
The latitude.
Going side to side?
Yeah.
That's a good question. Did anyone take that down in their notes by any chance? Let me see if I can find it. It was pretty early on, about when those tools started to come about.
It was in the 1700s is what I
1700s. Okay, we will actually be going more into the history of navigation after we talk about longitude, so some more of the dates will come in there. But that's a good question. Yeah, so there was a long period of time where there was basically very little ocean exploration. Okay, so remember then that this previewing is not a detailed note taking, it's just to basically look through, see what we're going to cover next. And then I believe on Monday, we will be starting the next lesson with longitude. Okay? Does anyone have any questions? Let me actually just figure out attendance here real quick. So we have, okay, and I know the one that was not able to get in. Okay, all right, I'm gonna let you guys go then. You can use this time to work on that or just rest between your next class, but just know by Monday that needs